My main research interests, they center around antibiotic resistance and sewage. Because in sewage, and especially sewage treatment plants, you can find conditions that might favor the development of antibiotic-resistant bacteria. Because there you can find really high numbers of bacteria, but also a high diversity of bacteria. That is, that you can find many different types of bacteria. And also, you can there find a high diversity of genetic factors that can be picked up by bacteria and render them resistant to antibiotics. And finally, you can also find antibiotics and other antibacterial substances at levels that might promote and favor antibiotic-resistant bacteria. So therefore, sewage and especially sewage treatment plants have been suggested to be hotspots for both emergence and selection of antibiotic-resistant bacteria. But although sewage treatment plants can reduce the bacterial load in the sewage water quite a lot, normally 100 to 1,000-fold, you can still find significant numbers of bacteria, including resistant ones, in the treated sewage that is leaving the treatment plants and is released to the neighboring environments. So therefore, treated sewage can contribute to the further dissemination of antibiotic-resistant bacteria. But I'm not only interested in what's going on inside the treatment plants and what is coming out from them. I'm also specifically interested in what's coming in to the treatment plants. And that is the raw, untreated sewage. Because raw, untreated sewage can be seen as pooled fecal samples from all individuals that contribute to the sewage. So we think that it would be a cost-effective way to analyze bacteria from such raw, untreated sewage samples to get a good picture of the resistance situation in the community contributing to the specific sewage sample. And thus, we believe that this kind of analysis can complement today's clinical surveillance system. And maybe even more importantly, that in parts of the world where a clinical surveillance system for antibiotic resistance is lacking, this kind of sewage surveillance can be even more valuable. I would say ever since my undergraduate studies, I've been fascinated about bacteria and how quickly they can adapt to new environments and new conditions. And when it comes to treating bacterial infections, I would say that there is no doubt that the most scary and most significant example of such a bacterial evolution is the development and spread of antibiotic resistance among disease-causing bacteria. And I would say that the combat of antibiotic resistance will require coordinated actions by many, many different players around the world, because this is really a global health problem. And if you can contribute just a little bit in this fight against antibiotic resistance, I think you have done a good thing.